Welcome to all. I am continuing the sequence of questions on these two blocks. This is almost lot but one class. Next class, one special question is there. With that one, these two blocks connected together will be over. Some will ask, why you are solving all these questions? See, first of all, this arrangement, even I don't know how this arrangement comes. It is pure imagination. So all these questions, remember, are taken from question papers, either university paper or some competitive examination where lengthy questions are there. So from there it is taken. I never take any question from the books. Sometimes it happens that what question I write here, somebody will tell, it is in that book. Let it be there. He or she also has taken from question paper only. Or maybe from that book in the examination question given. For me, it is question paper, that's all. I never open a book and search what questions they are doing. I have got enough confidence in myself only. Okay, see. Question 68. Two blocks 1 and 2, see here. This weight is 1100 Newton, 800 Newton. Connected by a rod, see, this is a rod, is placed on two inclined planes as shown in figure. Inclined planes as shown. Okay, this sketch. 55 degrees, 50 degrees. 0.3, 0.25 are friction coefficients. Okay, now, what is the question mean? See, you see here, suppose you apply a force this way here. What will happen? As you apply a force this way, this will start sliding down. When this starts sliding down, this link will be in compression. See, when you apply the force here, this connecting rod will be compression. That will push it like this. So, when this starts sliding down, automatically this has to go up. So, question is, see, common sense. When this is sliding down, when this is on the verge of sliding down, that should be on the verge of going up. See, both cannot slide down. How? See, this when you apply a force this way, if the tendency of force is to slide this one down, that is to go up. So, find the value of P when block 2 is on the verge of moving up the plane. Make a note. They are asking what value of P will make the block 2 on the verge of moving up the plane. Or you make a note. Same question they can tell. Find the value of P when block 1 is on the verge of sliding down. Both are same. You write here. Either they can, you make a note here. Either they can ask this question as find P when the block 2 is on the verge of moving up, or find P when the block 1 is on the verge of moving down. This question. Next question, I will apply force here and close this question. Okay. See here. First remember, all usual you have to write. Now, people, sometime it happens, people will tell, he is not explaining anything. Why should I explain? It is question number 68. Those who are serious, they will understand. I told again, not serious, you know what I tell. So my class, only those people can follow and understand thoroughly if they go through all the classes and practice and make a notes, necessary required notes, and they have to solve all the questions. Not briefly see the class as an entertainment video. I never call my class as video. See, of course, officially in YouTube, it is called video. I know it, I can't do anything. Upload a video, your video got so many views, that is there. But I consider it as a class only. Okay, start. Now, see, usual statement. Let P is required here. Let R1 be the normal reaction, R2 be the normal reaction. Then, see, block 2 is on the verge of moving up, means block 1 is on the verge of, you write here, block, we have to find P for block 2 on the verge of moving up. Block 2 on the verge of moving up means friction is down. How much? 0.25 into R2. Why means sorry. I will tell sorry. And when block 2 is on the verge of moving up, block 1 is on the verge of coming down, so friction is this way, 0.3 times R1. This P is parallel to the plane. This connecting rod is horizontal. See, they can give incline. If they give incline, you require angle, but usually they won't give inclined. It is horizontal, understood. See, connecting rod. And one more thing, see, no data given regarding the rod. So you write statement here, let C be compression force in connecting rod. In the connecting rod. This connecting rod, that, and one more thing is there. One examination, same question given, but they told weight of that rod. So make a note here. In the absence of data, see, this is 800 Newton is 80 kgs. This is 110 kgs. That weight may be very lightweight, maybe 2 kg, 3 kg like that. So when it is not given, understood that the connecting rod is of negligible weight, you can ignore it. Unless they give the weight. Next question, one examination, same question asked. They told you the weight of the rod. That is next question. Okay, nothing is there. If they give weight of the rod, it is equally distributed on these two. See, it is like a simply supported beam. So if they give weight of the rod as, say for example, some 200 Newton, it will press this weight 200 Newton, will press this down by 100, press this down by 100. So then this one, a load of 1100 plus another 100, see, 1100, where is it here, see, plus another 100, this will be 800 plus another 100, that's all. That's all, but next question, I will give it. Okay, now, this is the arrangement now, everything explained for you. Okay, start. Now, I should not tell each and every class. Unknown is for block 1, start from block 2. Or make a note. Block 2, here you are trying to show the compression. See, I forgot it. You have to show the compression here. Compression is like this. Somebody will ask doubt, sir, why it is compression? Go back to earlier class where one class I took exclusively for deciding compression tension. Go back to that one. Okay. It's a compression. See, compression, you push it. Okay, now, what I told? I forgot some. I want to tell something. Suddenly I forgot it. Okay. Why which one taught first? See here. Block 1, unknowns are R1, C and P. 3 unknowns. Block 2, R2 and C. So block 2 has less unknown. See correctly now. Consider, first go here. After this sketch, first go here. Consider equilibrium of block 2. Once you finish block 2, then you have to come to block 1. Or, easy method. If unknown is at block 1, if you can solve directly using block 1, then block 2 properties are not required. How it is possible? So unless you get that one, consider that one, you cannot come here. This also I told hundreds of times. Okay, start. See here. XX, YY. Anybody will ask, sir, what is this XX, YY? Not clear means discontinue my class, study somewhere else. See, XX, YY. Okay, now, weight 800 Newton. Where is it? 800 Newton. This is 50 means 40 degrees. Cos sine. R2. 0.25 R2. See here, 0.25 R2. See, this compression force C, which is making, see, this compression force C is making angle of horizontal with this plane making 50 degrees. So this is cos, this is sine. If you resolve C. Okay. Now this also I should not tell. Start. Sigma Fy 0 plus R2. I want first unknown first. See, I want to get, see, the purpose is to get C here. If you want to get P, first the correcting force C you require. So start from unknown C. See, sigma Fy 0, this way positive. See, minus C sin 50 plus R2 minus 800 sin 40 equal to 0. This is equation number 1. See, C and R2 both are there. Okay, no problem. Sigma Fx 0, you take this way positive. Then plus C cos 40, so C cos 50, okay, then minus 0.25 R2 minus 800 cos 40 equal to 0. Equation number 2 in terms of C and R2, solve it. R2 we are not interested. If you want, write R2. C will come plus 1642.88 Newton. Okay, over. Once you finish this one, see here. Now see correctly how I am solving. Once you finish this one, then come here. See, come here. You should see how I am writing. Okay, now consider equilibrium of block 1. See here. One force, pushing force, see here. By this time, this C is known for you, 1642.88. Weight 1100, down. Then one unknown force P along the plane. Friction 0.3 R1 and normal reaction R1. Okay. Start. Sigma Fy0, this is Yy, this is Xx, plus sigma Fy0 plus R1, see here, plus R1, then this is not there because these two are directly along Xx, then plus R1, see, minus 1642.88 into cos, sin 55, then minus 1100 sin 35, equal 35, when this is 55, then this is, then this is 55 degrees, see here, if this is 55 degrees, this is 35 degrees, already known for you, okay. Equal to 0, you get the value of R1, I already solved it. Once you get R1, sigma Fx0, take this way positive, right side, plus P minus 0.3 R1 plus 1100 cos 35, see here, then that's all, sorry, not over, then minus 1642.88 into cos 55 equal to 0, you get the value of P 634.261. Therefore, if you apply a force of 634.261 Newton to this parallel to the plane, the question can be anything. Then this block is on the verge of moving up, or they can ask you same question, block 1 is on the verge of coming down. Question number 68 over. Now, I will start 69. Last question today. I actually from native place, just now I came back. So today actually feeling a little tired. But I decided, no, class should not be discontinued, 69. Two blocks 1 and 2 connected by a rod, okay, see, connected by a rod of weight, not too much, 200 Newton. Okay, 200 Newton. Not one, but not that much, 20 kgs, that much weight will not. 150 Newton, okay. 150 Newton, two blocks and two connected. Are placed, see, are placed, that is the two rods which is connected by a rod of weight 150 Newton, are placed on two inclined planes as shown in the figure. Same thing. Weight I will not change. I will maintain same weight. Why? So that you can compare the answer. You take an independent question. Okay. Now, find the value of P when block 1 is on the verge of moving up the plane. Last time, find the value of P when block 2 is on the verge of what? Verge of going up. Now, they are applying a force not there. See, they are applying force here. Here, force. This is P. This is P. See, now you have to apply from this side. They are asking you, find what is the value of P when the block 2 is on the verge of coming down. When the block 2 is on the verge of coming down, it is as good as asking block 1 is on the verge of moving up. So in the question, they can ask you either find P when the block 1 is on the verge of moving up, or they can ask same question as find the value of P when the block 2 is on the verge of moving down the plane. Okay. Put this sketch. Now, this is C. One small important you are right now, extra. See, let C be compression force in the connecting rod. Okay, now, one statement I will give you, you should write it here. See, no place to write here. I will dictate. Consider the connecting rod. See, connecting rod. Its weight is total 150 Newton. This is a connecting rod. Now, this is connecting rod here. Total 150 Newton weight. Therefore, this connecting rod of weight 150 Newton will press both block 1 this way. It will press block 1 and block 2 by half of 150 by 2 equal to 75 Newton. This also 150 by 2 equal to 75 Newton. Therefore, right here, for block 1, the final vertical load will be 1100 plus how much? 75. Okay, that's the only change. 1175 Newton. It is as good as telling this weight is 1175 Newton, and here it is 800 plus 75 equal to 875 Newton. So when you write free body, see block 2 you should write 875 and block 1 you should write 1175. Okay, now one more thing. I will explain and then go for changes. Now block 1 is on the what is this one? Block 1 is on the verge of moving up. See, block 1 is on the verge of moving up means friction is down. See, careful. This is on the verge of, see, when you apply the force, see, force is here. Your force is here, P. When you apply this force, block 1 is on the verge of moving up, friction down. And when you apply the force here, when it is on the verge of moving up, this is on the verge of coming down, friction is like this. This all you have to make a note. That's the only change. But one more change is there. Now, you should not go there. See, now first you have to start from here. See, not there. See now block 1 has unknowns. See here, block 1 has unknowns P, comma, then. Oh, no, sorry, not here. This is not there. Block 1 has unknown, not P. See, R1 and C. Whereas block 2 has unknown R2, then P and C. So there are 3 unknowns here, 2 unknowns here. So first you have to consider, see, from here you have to come here. Not there, later. So first, see correctly how I solve, you should write that way. First consider, when you start, consider equilibrium of block 1 or reason. If unknown is here, first consider that block. If unknown is there, first consider this block. Okay, now when you consider equilibrium of block 1, which one? Block, which one first? Block 1 first. See, this P is not there. Then 0.3 onward direction is reversed. Then R1 is same direction. Instead of 1100, 1175. Angles all will remain same. Compression is not known. Compression is unknown. See, compression is unknown. It will be known later. Now you get the value of C. 1 minute now. You solve it and get the value of C. Then go to block 2. Okay, I will do one thing now. I will solve, get the value, and then I will continue. Okay, now I already explained everything. This is finding the force P here, see, so that block 2 is on the verge of sliding down, friction up. When this is sliding down, this will go up, friction down. This all told for you. See, now this is C as usual, all statements same. Little change in the weight. We added that extra weight. Okay. Now, see, last time unknown was here. 3 unknowns here because the P was here. There 2 unknown. So last question we considered block C. Last question your P was here. So see, P was here. You considered block 2, then come to block 1. But this time your P is here. So now you have to first consider block 1. See, consider block 1 or see here. Block 1 has got R1 and C. Block 2 has got R2, P and C. Or where unknown is there, Consider other block first. Hundreds of times told. Okay. So after this question, first come here. Consider equilibrium of block 1. Note the fiction correctly. Block 1. See. Block 1 is here. R1 55 degrees. So this is horizontal with the x-axis makes 55 degrees. Then R1, 0.3 R1, everything is over. So start. Sigma Fy0. Take upward positive. Then plus R1, or unknown first. See, our important is C. Minus C sine 55 plus R1 minus 1175 sine 35 equal to 0. Equation number 1. Hundreds of time explained. Okay. Sigma Fx0, we will take right side positive. Start this way, right side going. Then, see, minus C cos 55 plus 0.3 R1 plus 1175 cos 35 equal to 0. Solve 1 and 2, you get C, and also you will get R1. R1 you write, I don't want R1, because when you go to next block, block 2 we want C value. R1 is extra answer. You write, solving, you get C and also R1. Okay. Some exam they may ask you, find the normal reaction. See, then you require it. Okay, now, after this is block 1 is over, now come to equilibrium of block 2. See, block 2. P 0.25 R2, R2, this compression force this way. See, it is horizontal makes 50 degrees here. So, with the horizontal it makes, it is parallel, it's horizontal. So, if it is horizontal, with this axis, it makes 50 degrees here. Be careful. See, this horizontal with this axis makes 55 degrees, but with this axis, it makes 50 degrees. We should be careful. Okay, that all high school mathematics. Okay, we can make out here only. Okay, start. Sigma Fy0 plus R2 upward positive. This is not there, this is not there because why? Directly along x-axis. Then minus 875 sine 40 minus 3552.715, that is R2 value, into sine 50 equal to 0. You get the value of R2. Sigma Fx0, take this way, right side positive. You get minus P, see, plus 0.25 R2. Is it correct answer? I don't know. I'll check the answer. Plus 0.25 R2, then minus 875 cos 40, then see, plus 3552.715 into cos 50 equal to 0. I got doubt about that answer. Have I taken negative correctly? I will see it now. See, no problem. 0.25 into R2 is 3283.977. That is positive. That is positive. Then minus 875 into cos 40. Lastly, plus 3552.715 into cos 50. 2231, I see 2231 point. Okay, 1 minute. I'm getting different answer now. Plus 2231 point, I don't know calculator problem. 767. 767. Okay, do one thing. I will not check once again. When I wrote everything, substitute the value of, see, here you are right here in this equation, what you have to do? Substitute for R2. R2. If it is wrong, you correct the answer. No point in wasting time to check this once again. See, everything is known. Substitute and get the value of P. I think it is correct most probably. Anyway, these small things, throughout this course, when everything is written there, when you have solved something, when unknown is 1, everything is known. If I make a substitution mistake, you don't bother. See, such mistake will not happen in SFT BMD. Or in indeterminate structure, such mistake will not happen because 99% of the indeterminate questions, people who take more than 1 hour to solve, I can solve by shortcut in around 5-6 minutes. Some of the question in just 30-40 seconds. Tricks are there. So there I know the answer. And one more thing, When you solve by 3 different methods, answer has to tally. So therefore, when only calculation part is there, see friction chapter, see moment of inertia also, see, I never used to give the answer. I used to write the expression and tell, now you find it. Those who are serious find it. Okay. If it is wrong, correct it. That's all. I'll conclude the class now. Next class, see, one special question is there. I'll tell you what is the question. I see the question paper there. See, one inclined plane here and one this way. One horizontal plane, one inclined plane connected by a rod. This question, in so many university papers, it is asked from 4 or 5 times. So this I will solve 2 times. Once to move it, one to bring it down, once to take it up. With that, I will conclude these 2 block questions. Then I will go for next part. And after next part, some special questions are there. One block placed over other block. Then relative friction is very important. Then you will go for wedge friction. And lastly, very interesting part, that is ladder friction. Ladder friction is very, very interesting. Okay. Thank you. Next class we will meet.